Hello and welcome. So today I want to share with you a story about how one small change in our DNA can create a big impact. And that is the story of PACS2 syndrome. So let me start with asking you to imagine this with me. Jennifer and Jason have just welcomed their first newborn into their family. They're soaked in the excitement, the endless sleepless nights of course, changing diapers. That is always enjoyable. But soon enough, one night, they notice something is off. They notice their baby have sudden little jerk movements, almost like glitches. And the baby is not hitting developmental milestones as other babies are around that age. So feeling concerned, they go to see a pediatrician. After months of clinic visits and testing, they finally figure out an answer through genetic testing. And the answer is PACS2 syndrome. So Jennifer and Jason feel confused, helpless, and overwhelmed. What is this PACS2 syndrome? Why their baby? There is no family history of developmental disorders or any kinds of genetic disorders in the family. And how did this happen? So in Dr. Alicia Gomez-Gamboa's lab, that is exactly the question I look at, the root cause of PACS2 syndrome. Here, this is what we do know as of right now about PACS2 syndrome, that it is caused by this single uninherited mutation. So what does that mean? I have some example clips of parents and PACS2 children's DNA. As you can see here, there is only one misspelling in the DNA between these two. Only that one misspelling can cause real symptoms. And what's even more surprising is that it's almost always random. So it's not inherited. The kid does not get it from either the mom or the dad side. In other words, the variant happens for the first time in that child. It's something that no one could have seen or prevented. It's almost like a typo in a paragraph that pops up by chance. So here I'm showing you photos of children that are impacted by PACS2 syndrome. They all are happy children. Until you look closely enough, you may notice some of them share certain common physical features. So you might notice they have wider set eyes, broader mouth, and also thinner upper lips. So some other hallmark symptoms about PACS2 syndrome that I can't show you, unfortunately, through photos include epilepsies, developmental delays, challenges with eating, movement, and speech. Right now, PACS2 syndrome is a rare condition that we don't have treatment of, and it is also life-limiting. This is a very recently reported diagnosis, as recent as firstly reported in 2018. And that partially explains the reason why we just don't know enough how it impacts long-term health and life expectancy. So the question becomes, how can we move from there? What's the next step? How does this single point mutation leads to those real-life symptoms that are devastating to children? And that's where my research comes in. My name is Siyi Wang. I am a master's student in the neurobiology program here at Northwestern. Under Dr. Alicia Gomez-Gamboa, I study PACS2 syndrome, trying to understand the pathological mechanism of it with the ultimate goal of developing treatment. So this is how I do it in my lab. We use samples collected from blood and also skin biopsies. And using a special reprogramming process, we develop them into neurons. And these are actually real neurons that I capture using the microscope in our lab. Neurons are brain cells. So one important question that we can ask by having the neurons developed from samples collected from healthy and PACS2 patients can be, for example, are there more neurons dying off in one group than the other? Are they developing, are they growing, maturing differently between different groups? And neurons, importantly, they communicate with each other, they talk with each other through firing electric signals. So are they communicating with each other abnormally in one group? On the left here, I have a schematic of what it looks like for neurons being plated in a neuron plate where we capture those electric signals. And on the right, this is a figure of what the patterns look like when we record them. So coming from there, by being able to compare the differences, I'm able to understand more about the underlying pathological mechanism. And from there, we can start applying drugs to cells to explore potential treatments and other therapies that can hopefully alleviate symptoms and restore patient function. So my message today is to stay hopeful. Even for rare conditions like PACS2 syndrome, there is ongoing active research. We work hard to understand and to treat PACS2 syndrome, hopefully one day. And this progress, of course, depends on so close collaboration between research scientists, clinicians, and of course, PACS2 patients and their family members. And of course, even you as taxpayers who help fund this critical work. Together, we bring hope to family like Jason and Jennifer's. Last but not least, I want to acknowledge and appreciate the teams that I have that made all of this important work possible. So this is my lab team under Dr. Alicia Guemes-Gamboa, sitting right here. And this is my lab family where I do all of those important neuron work at. And this is my RCTP family where I have been taught so much about how to talk about science in a very accessible way. So thank you all for being here today.